All right, let's talk about graphs of data. First, different types of data. Data can be classified as either categorical or quantitative. Categorical data means that you would answer with words like color of eyes or the favorite type of cereal. Quantitative data means you're going to answer with a number. Quantitative data can be further subcategorized as either discrete or continuous. So discrete data is data that's a result of counting. You have exact values. And an example of that could be like the number of people in a car or the number of people that live in your home. Continuous data is going to be a result of measuring. So you have a range of values because like height is an example because somebody could be 60 inches, somebody could be 60.2 inches, 60.7 inches. And so you're going to get a continuous possible range of values. So first examples, I'd like you to classify these as either categorical, quantitative discrete, or quantitative continuous. So pause the video and try these problems. So you should have labeled the first one as discrete or quantitative discrete, the second one as categorical. So just backing up here, the number of heads, obviously the number of something, meaning you're counting it. So that's why it's discrete. The brand toothpaste, so you would answer the question with something like Colgate or Crest. Finally, the heights of groups of 15-year-old children, that's going to be continuous. Next up, organizing and displaying categorical data. So you can organize categorical data a few different ways. A common one is to do what's called a tally and frequency table, where you could put your type of, whatever your categories are in this case, it's your fuel type. And if you want to make an extra column for your little tally marks, for example, if you were watching people at a gas station and you were going to tally the type of fuel that they choose for their vehicle, and then you add the tallies as you're observing, and then another column for their frequencies at the end. You can also use what's called a vertical column graph or a horizontal bar chart. So you can see that same data where you're talking about the fuel type organized in this is sometimes called a bar graph, or what's called here a column graph, or the horizontal bar chart. Same thing, but you're just putting the frequencies along the horizontal axis. So number 2, multiple choice question. Pause the video, answer this question. One thing that to notice here is that this bar graph is sort of misleading. Not sort of misleading, it's very misleading because you have the very lowest measure as 94% and the highest measure is 96%. So if you weren't paying attention to that, you might think the Chevrolet drivers are very much more satisfied with their vehicle than the Ford drivers or the Toyota drivers. But in fact, the answer is C. There's very little difference in the satisfaction of the owners for the 3 brands. I'm talking 94% versus, well, this would be more than 94. This would be like 94.5, up here to 97, it might be 94.8 or something like that. So those are pretty close measurements. Displaying categorical data and other types of charts you might see would be a pie chart, sometimes called a circle graph or a circle chart. You've seen these before. And then a segmented bar chart, something like this, where you could have the whole quantity here, and then you're segmenting it into the number that are choosing unleaded fuel. This light blue is the number that are choosing leaded, the darker gray, whatever LPG is, and then that dark blue diesel fuel. Organizing and displaying discrete quantitative data. So you can also use a tally and frequency table if you're just counting something. So if this 3, 4, 5, 6, 7, maybe that represents the number of people that live in your home. And if you were standing at the door of the school and you were asking people as they walked in, how many people live in your home, and you just put a little tally mark as they answer the question, and then in the end you can count up your frequency. So organizing discrete quantitative data, and in addition to doing your tally and frequency table, you can also do a dot plot, a stem plot, sometimes called a stem and leaf plot, or you can also do another bar graph or a column graph. So you'll notice that for the dot plot, this is the same actually information for this data here. Maybe that represents the number of people that live in the home. I don't really know. And you just put a little dot to represent each time that number occurred. Some advantages here, it's easy to see the shape of the distribution, which we'll talk about that later, but it is difficult to make for large data sets. So you can imagine that it would be very tedious to have to make 50 or more dots for one particular value. The stem and leaf plot, you got the one side is the stem and the other side is called the leaf or your leaves. So over here, then you also have like a key, which down here says 1/7 means 170. So whenever you have a stem plot, you should always have some sort of a key that tells you what this represents. So this stem here would be 1, and then this is a separate, so that's 1/7, so it'll be 170, and then 1 would be 110, so that's a whole separate value. And then you have 280 represented with that, 230 with that one, 260 for that one, and so on. So that's how you would read the stem and leaf plot. Notice that the leaf must always be a one-digit number, and then don't forget the key. It's also very easy to see the shape of the distribution, but again, it's difficult to make for a large data set. Your bar graph or your column graph, it's easy to see the shape of the distribution, and this one is easier to make for a large data set. As you can see, for each value, once you figure out what their frequency is, you just draw a single bar. Let's take a look at this example. It says a group of students were asked, oh, there's a typo here, for the number of hours that they read for pleasure each day. And then we have those values here in this table. We're going to make a dot plot, and we'll give the dot plot a title. So I'm going to make a number line here, and then I'm going to make a dot. So we can just go through the table one by one. And so, for example, I have put a dot for the 1 hour per week, and then I have a 2, and then I have a 3, 4, 5, and a 0, 4, 5, and 0, and so on and so forth. Okay, when you're doing this, you're going to want to make sure that all of the first dots line up horizontally and the second dots and so on, because you don't want to make, for example, you don't want to make all these dots be too close together so that it looks like this column of dots is the same height as that column of dots, because you want to be able to see the distribution. So make sure that you are evenly spacing these dots as you make them, and give the dot plot a title. Okay, part B, what conclusions can you draw with regard to the number of hours the students read for pleasure? Well, I would say most students. What percent of the students spend 5 hours reading for pleasure? Okay, since they're asking for percent, we need to know how many total students were in the survey here. We know that 2 of them read 5 hours. We need to know how many total. You could, of course, just count up the number of numbers that we have in this rectangle. You could count up the number of dots that you have total. The total is 20, so that's 10%. 10% spend 5 hours reading for pleasure. Okay, next up. Professor Smith's exam scores are given in the STEM plot. So here's the stem and leaf plot here. We have a key or a scale down here that says 7/2 means 72. So this person obviously got a 33%, and this person got a 100%. We want to find the number of scores with a value of at least 60. So at least 60 would be all of these here. So you just want to count the number that you have there. Take a second to do that. And there are 24. And then count the number of scores that have a value of less than 45. So you got that 33% and then a 42%. So there's 2. Find the percentage of scores that are greater than 90. So you want to look at all of these scores and then divide by the total number of scores that you have. So you also need to count out the total number of scores that you have. Well, there are 8 that have a score of greater than 90. And there are a total of 31 scores. So that makes a percentage of 25.8%. What conclusions can you draw with regard to the scores the students received on the exam? There's really no wrong answer here. I mean, as long as your conclusion comes from the data that you have there. But you might say something like most students scored between 60 and 100. About 26% earned 90 or higher. Now, you could say an A, but the truth is we don't know about Professor Smith of whether or not an A is a 90 at his school. I've worked at a school where 92% was considered an A, and then 91 was a B+. You could also say something about, you could calculate the number that scored below a 60. So you could talk about those percentages that scored below 60. So there's a few different conclusions that you can make here. Okay, for this example, we have a bakery keeps a record of how many pies and cakes they sell each month. So here's all the information for the pies, and here's all the information for the cakes. We're going to draw a back-to-back stem and leaf plot to display this data. We'll find the modal class and then answer this question. So first I want to take a look at like the highest and the lowest, or the minimum and the maximum. For the pies, I see that 47 is the minimum and 85 is the maximum. For the cake, I see that 37 is the minimum and 76 is the maximum. So I need 2 vertical bars because I'm going to need to show the numbers 3. Let me write down the numbers first, and then I'll do the vertical bars. 3, 4, 5, 6, 7, and 8. Okay, I'm going to have to write much smaller. Okay, we do a vertical bar here and a vertical bar here. So we can do the pies first. Let's put the pies on the left-hand side. Pies. I didn't give myself enough space to show this work. And then sometimes we like to go in order, but not required. So we don't have any pies that would be 30-something pies, but we do have that 47. So we can put in a 7 over here to the left of the pies, and let's cross off that value. We have that one. There's a 48, I see, a 48 there. and there's a 49. Now, just to show you how it works, I'm going to go ahead and jump over to the cake. So for the cakes, the smallest number of cakes, of course, is 37. So we can put a 7 there. Then I have also a 38 cakes. And so you kind of get the idea that to the left, we're just putting our number of pies, and then to the right, we're doing our number of cake. All right, you pause the video, and I'm going to finish this, and you finish it too. Okay, I finished my back-to-back stem and leaf plot. One thing I haven't quite written yet that I need to do is I need to include the key. So we can just say something like 6/0 means 60. Just some sort of a key or scale so that the reader knows what these numbers represent. And of course, it would be more important, especially if I had more space, to label the cakes to the right-hand side of that vertical line and the pies to the left. All right, so we did part A. Find the modal class for each data set. So when they say modal class, so for the pies, which class, like which branch or leaves had the most? So you can see that it was between the 70 and 79. And then for the cakes, it looks like the modal class would be between 50 and 59. For part C, does the bakery generally sell more pies or cakes? I think it's pretty clear that they sell more pies. And if you wanted to give a reason, you can say that they have more pies that are being sold in the 60 to 69 and the 70 to 79 range. All right, that's it.